Another pigment which I am going to talk about is, some people have not joined, I think only Ajankya, Karnake, Samidha, Pranav, Santosh, then Badnakhe, Swami. किती जण आहे आज?
सर आज 10 जण जॉईन झाले आहेत.
10 जण आहे सर.
So I think it is time that we can start now our discussion.
Yes, sir.
You can keep your phone so that when I want that you should refer to phone, then you can refer to phone. Just a minute. Now can you listen me?
Yes, sir.
Yes, sir.
So we start our discussion on zinc oxide pigments. Is it not? We have already completed titanium dioxide. Now we want to switch over to zinc oxide. This is also known as artist Chinese white. The common name is also artist Chinese white. To tell you frankly, the use of zinc oxide as a pigment has reduced considerably after various grades of titanium dioxide are available. Once various grades of titanium dioxide are available, earlier zinc oxide was used in huge quantities, but later on they have been reduced because lot of function of zinc oxide is done by titanium dioxide. But yet zinc oxide is used in several formulations. Where it is used, why it is used, you can write down. Okay. Number one, it is used for gloss retention in alkyd paints. Gloss retention in alkyd paints. Now let me explain you that what is this gloss retention. When you prepare a highly glossy paint, that means a paint which reflects like mirror. A paint which reflects like mirror, best possible paint, it will give the highest gloss. But there is a phenomena which is known as dulling of gloss. Means after some time, the gloss go on reducing. Why it is reduced? Because there is deposition of moisture. Because of the climatic condition, moisture is there, seawater is, your structure is near the seawater, or damp climate is there. So under these conditions, the moisture gets deposited on the film and it reduces the gloss. So zinc oxide is a pigment which prevents this gloss reduction, because it does not allow the moisture to be deposited on the finished surface. Therefore, zinc oxide is important. Normally, in alkyd gloss or wall finishes, it is used to the extent of 2 to 3%. The other thing which is important, it is used in anti-fouling paints. It can work against microorganisms, molluscs, and green mildew which is there. कंजी बोलते हैं ना, हरियाली जमती है देखो, हैं? So that thing, particularly when you go to the towards sea or sea structures which are there is always a greenish deposit. Whether it is an offshore sea structure or ship or boat or anything, there will be green algae may be deposited. Is it not? So zinc oxide is a particular pigment which is used to take care, prevention rather, of this mildew disruption of the surface. This is second use. There is one more use which has not been mentioned in the books, but we have practically observed. In earlier times in Holland, touch paints were prepared based only on zinc oxide and stand linseed oil. Earlier, try to understand the difficulty. Alkyd was not known. Zinc was a very hard pigment. And stand oil is a softer binder. Is it not? Stand oil is a softer binder, while zinc oxide is the hardest paint. So if I blend 30% of zinc oxide with linseed oil, stand oil or boiled oil, it will give a good composition, which is quite thick, quite attractive, having good hiding power. But this kind of compositions have not been stopped. Why? Because titanium is available commercially in all grades. So direct use of zinc oxide is not very beneficial. One more thing is there, which I must tell about zinc oxide, is the fact that zinc oxide is basic in nature. Write down. Zinc oxide is basic in nature. And many of the binders, particularly alkyd resins, epoxy resins, silicone resins, they have some acidity. Some acidity. So this zinc oxide reacts with the acids and form a good dispersion. The thickness of the paint is controlled. And small soap which is formed, it helps to disperse the medium and remaining pigment. But a limited amount of zinc oxide should be used. Remember, for this reason, if I go on adding zinc oxide, say from 3 to 5%, 5 to 10%, or 10 to 15%, what will happen? There will be a seeding. A thick useless mass may be soap बन जाएगा, surface के ऊपर soap बन जाएगा, which is not expected. Just smaller amount, production of smaller soap of zinc helps in getting thickness, a good paint consistency, and application properties to the paint. Normally speaking, 1 to 3% zinc oxide is more than sufficient. Not more than 3% zinc oxide will be used in common formulation. And that too with due care, because there is a problem in packed materials that is known as seeding. So if you close the container and allow it to keep, whatever remaining zinc oxide is there, it will go on reacting with the medium. And when you open the can, the whole thing may be solidified. This should not happen. Judicious care is required in utilizing zinc oxide. Now, how this zinc oxide is produced? There are two methods. One is known as direct process. Write down, manufacture of zinc oxide. Manufacture of zinc oxide. The ore is known as zinc blende. ZINCBLENDE, zinc blende. It is mainly zinc carbonate, but other impurities, iron, magnesium, etc., may also be there in the natural product. So, in direct process, the ore is mixed with coal or coke. The ore is mixed with coke or coal and heated in a furnace. The ore is reduced to metal. The temperature you have to keep more than 490 degrees, means above 420 degrees temperature is required. Then only zinc will volatilize. All these are very high temperature processes where you have to go to very high temperature of 450 to 500 degrees centigrade. So when you reach this temperature, zinc will volatilize. Then it is asked to mix with a current of air. This vapor of zinc, when it starts coming out around 420 degrees centigrade, at this temperature, these fumes or vapors of zinc, air is blown so that this zinc fume comes in contact with the air and directly it is converted to zinc oxide. This stream is controlled and temperature is reduced gradually. So at the end, when you come to lower temperatures, what happens? Zinc oxide is coming out as a mass. White powder. I would say not mass, I would call it white powder. This white powder is collected. This is nothing but zinc oxide. Try to understand the basics of the process. Basic is metal is burnt, or whatever ore is there, whether it is zinc blende or something else, it is subjected to heating to very high temperature. Sometimes along with carbon, sometimes without carbon, but heated high temperature. After melting point, it has a particular habit of forming vapors. Those vapors are made to react with air. Air is blown through pipes and that air and zinc vapor, they come in contact and form zinc oxide. That is collected ultimately. This powder is collected. But in this direct process, there is a impurity of basic lead sulfate up to 5%. Basic lead sulfate impurity is around 5%. Indirect process is a better process because it gives zinc oxide of better purity and whiteness. Indirect process. There are a series of crucibles. आपने लैब में क्रूसिबल देखा होगा, है ना? So crucible type of retorts are there in a series, 1, 2, 3, 4, 5 of huge capacity, and they are heated very strongly, and they are covered. There are lids which cover the crucibles, and there are small openings through which fumes go out. And these fumes, they meet air. As they go out, there is another inlet through which air is blown. So air and this zinc vapor, they come in contact. It is all high temperature reaction, 500 degrees centigrade and more. 5 times your boiling water. Just remember. So first at high temperature, what happens? The whole thing gets reacted, and then we start in stages, we cool it. And on cooling, we get a powder ultimately, which is nothing but zinc oxide. Okay. So now you can refer to page number 2. Open up your WhatsApp. Page number 2. Here we give characteristics of zinc oxide. Specific gravity is very high, 5.65, very heavy. That means if you keep it in a beaker, add water, it will have a tendency to settle down. Refractive index is 2. It's a good pigment, but not as good as titanium dioxide. Titanium dioxide has a refractive index of 2.7, while this has a refractive index of 2 only. Then oil absorption, grams per 100 grams, is 16 to 23. This oil absorption data is particularly important because when you formulate a paint, if oil absorption is less, you prefer that pigment because the oil consumed, because initially the pigment will try to absorb some binder. The lesser it absorbs, better it is it not? But here it is quite high, about 16 to 23 grams per 100 grams. Then mean particle size 0.2 to 0.35 micrometers. As far uses are concerned, there is a property which is known as fungistatic property, Fungistatic. Fungistatic properties are there. And particularly we meet that in emulsion paint, acrylic emulsion paint, polyurethane emulsion paints. In emulsion paints, you come across this problem of development of fungi because of the moisture and impurities present in the environment. Particularly near the seashore, these problems are more because the climate there is damp. Do you know that in coastal areas, the moisture content is always high, and therefore textile mills are always located on either the seashore or river shore. Why? Because near the seashore, the moisture content is always higher. This is one application. The other is gloss retention. I have already told you about it. About 2 to 3% will give good gloss retention. Now, zinc oxide is a bit costlier item. So how to identify zinc oxide? Identification, simple identification test of zinc oxide. Very simple test is if you heat zinc oxide powder, if it is pure zinc oxide, it will turn yellow. It will turn yellow, and on cooling, it will recur in color to white. पहले white रहेगा, हीट कर दो उसको, हीट करने पे वो येलो हो जाएगा. If you cool it again, it will revert in color to white. It will revert in color to white. There is another test in which the pigment is moistened with cobalt chloride solution. if you moisten the pigment with cobalt chloride solution and heat it, a green color is produced. Green color is produced. So as far as identification is concerned, it is quite simple. What is to be done? Heat it, it becomes yellow. Cool it, it will again become white, revert in color. Or if you add cobalt chloride solution, then on heating, it will become green. If this happens, means your powder is showing the presence of zinc oxide. It is just an identification test, not a gravimetric analysis. Okay. So, as far as white pigments are concerned, we only deal with these two pigments because the difficulty is this, that the whole pen technology syllabus has been covered in one paper, which is almost impossible. Earlier, we had oil and paint technology combined. But paint is using some oil, therefore, application of oil paint technology is there. So although I want to teach in as detail as possible, but there are practical limitations. We cannot talk about all the things because we have hardly 40 periods at our disposal maximum. So white I will discuss only two, titanium and zinc oxide. If you are interested, you can read yourself. The zinc sulfide pigment or others are there, you can read yourself. Okay. Now we start the next thing, that is about extenders. Extenders. Normally, you can open page 3 on your WhatsApp. Open page 3 on your WhatsApp. Now, various excellent grinding processes are available, and therefore, you can grind the pigments and extender to very fine particle size. Earlier, the equipments were not going good. So larger particles created problems. But nowadays, extremely fluid mills, energy mills, so many equipments have come by which you can get the finest possible powder. So particle size now is not a problem. Finally divided chemically inert material. Finally divided, definition of extender. Finally divided chemically inert material which may be processed mineral or synthetic material. Normally, the refractive index of all extenders is 1.7 or less. What is the refractive index of extenders? 1.7 or less. And most of the oils, resins, epoxies, they have a refractive index in the range of 1.4 to 1.6. So hiding is a property which depends mainly on difference in refractive index of the medium and the pigment. Two things are there, medium and pigment. If there is a difference in refractive index, it will show hiding. If there is no difference in refractive index, it will be transparent. So all extenders basically they favor transparency. They are not hiding the surface. The more common examples are gypsum, calcium carbonate, natural calcium carbonate, precipitated calcium carbonate, calcium sulfate. barytes, Barytes. Barytes means barium sulfate. Barytes, barytes. This is an extender. Now you may have a question. They are cheaper, okay, but they do not contribute to hiding. Then why we are using? We should not use them, is it not? But still, in most of the practical compositions, we are using extenders. I will give you. Number one reason is economy. All extenders are available at a very low price. Dolomite, 4 rupees, China clay, 5 rupees, Barytes, 7 to 8 rupees per kg. While titanium, 260 rupees, white anatase, 170 rupees, something like that. So if you try to formulate a paint totally on these hiding pigments, it will be very costly. If I use 5 to 10% extender, the price of the paint will come down. But only price is not the main factor. There are other positive aspects in extenders also. I will give you an example. Suppose you make a red oxide primer paint. You are using 50% red oxide, okay? 40 to 50% pigment is used in red oxide primer. Now, it will have a tendency to settle at the bottom. Once you make the paint, keep it for few hours, a part of red oxide will have a tendency to come to the bottom. But if I add either precipitated calcium carbonate or calcium carbonate 2 to 3%, that will help to keep the suspension stable. The paint will have good stability, a good emulsion, and good application property also. All these properties are given by extenders, means homogeneity is increased, the overall mass becomes uniform because of the use of extenders. Of course, limited extender is 5 to 10%. If you use too much, it will spoil all the character. But if you use in smaller amount, that smaller amount will certainly help to control the consistency of the paint. The chances of separation are very less. Consistency is maintained. One more factor which is important, that always you do not require very high gloss. Suppose synthetic enamel which you make for car or furniture should have high gloss. But if I am making a wall finish, there I don't need shine at all. I don't need any shine. Or I want a lesser shine. So how to control this shine? Add extender. That is known as flattening of the paint. Control the gloss character of the paint. Particularly in wall finishes, cement primer, etc., gloss is not required. There are some compositions where gloss is not required at all. Particularly in defense, camouflage paints are prepared. Camouflage paints means given to trucks or armors which are moving in the jungle or at the war front. If they are visible from the top, they will be bombed. So what I want, that their gloss value should be 0. How to achieve it? Add extenders. By adding extender, you will reduce the gloss to a considerable extent. Price is one factor. Homogeneity is another positive contribution of the extender. Then suspension stability is the third important character which is given by the extender. On an average, we can say that 5 to extender is a good amount which you can use. अब इसमें ऐसा है कि if you go to small scale industry, price adjustment के लिए extender बढ़ा देते हैं. They make some paints in which extender should be 7 or 8%, but they use 20%. Why? To reduce the cost. And particularly when they are giving railways or government orders where nobody bothers about the quality, then at that place more extenders are used. पिगमेंट से ज्यादा लोग एक्सटेंडर खरीदी करते हैं. Why? Because they reduce the cost ultimately. Did not, of course, by using excessive extenders, we will create so many problems. Gloss will not be there, hiding will not be there. But yet in low cost paint and particularly undercoats, putties are there. Putty, undercoat, second grade coats, in all these extenders are required. Because inside you do not require any gloss because that will be covered by the finishing paint. So naturally, if I want to make a undercoat, if I want to make a putty, if I want to make a surfacer, then I must use extender to a greater extent. Because in putty you cannot have a very high cost. Putty is very cheap. So there the use of extender is very common. Putties contain a huge proportion of extenders. Is it not? So that is the use of extenders. Now let us talk about some extenders. The first of them is barytes, Barytes. Barytes is a very heavy pigment. And see your page 4. Please turn over to page 4 on your WhatsApp. Here you see the figures. Specific gravity is 4.5, very heavy. It will increase the bulk density of the paint. Then refractive index is 1.67, so below 1.7, but nearing to 1.7. Oil absorption is 10 to 12. Now, one interesting point I will tell you that all these preparations, they are transparent when you use oil base or resin base, because the difference in refractive index of oil and these materials is very small. But when you go to water-based paints, compared to water, they have got somewhat higher refractive index, and therefore they will show some covering in water paints. Simple example आपको देता हूं मैं. Suppose you use whiting. अपन जो चूना लगाते हैं ना, white, cheapest kind of paint which is available. So whiting has some hiding power. पूरा तो कवर नहीं करता वो, पर कुछ हाइडिंग पावर रहता है. क्यों रहता है? क्योंकि पानी और व्हाइटिंग के रिफ्रैक्टिव इंडेक्स में फर्क है. जहां फर्क है वहां पे थोड़ा हाइडिंग आ जाता है. And particularly when we are depending more on water-based resin or water is there in the composition, the difference in refractive index of water and pigment becomes significant. And there to some extent, they can hide the surface. So instead of calling them extenders, we should also call them auxiliary pigments, just helping to control the quality of paint. These are non-toxic in nature. Most important thing about zinc oxide or barytes is this, that they are non-toxic in nature. In all the pigments, lead containing pigments have totally been eradicated from paint industry because of the poisonous nature of lead. Today, in the world of eco-friendly environment, we have to search for pigments which are free from any toxicity. So in that respect, barytes, calcium carbonate, they are all safer extenders. They do not cause any direct toxicity. That is a proven fact. The next important is whiting or calcium carbonate. In extenders, we have the next thing is calcium carbonate or whiting. This is also known as Paris white. Natural chalk, which is available in mines. We have got very good mines in Mandsaur, Neemuch MP, and many other places. We have very good deposits of natural chalk. If you go through train, we used to go towards Ajmer. So there are towns, Mandsaur, Neemuch. So this sticks were available. Natural chalk sticks were available. They are in huge quantity. Now, as far as whiting is concerned, there are two ways in which it is processed. One is wet process. Wet process, W-E-T, wet in a gila, and dry process. In wet process, first the natural material is powdered. First, the natural material is powdered, and then it is brought into dynamic contact with water. बड़े बड़े वाटर के स्ट्रीम्स में उसको ये करते हैं, तो उससे क्या होता है, impurities are eliminated and the quality is improved, and then it is again dried and used. In dry grinding, there are very good equipments. Pin mill is there. This pin mill is very good equipment for fine grinding of the powder. Now, whiting is a very important ingredient of a large number of paints. Whiting is used in primers to the extent of 2 to 3%. Then it is used in undercoats. Then it is used in putties, alkyd-based putty, oil-based putty. In all these preparations, whiting is always there. So whiting is a material which is consumed in larger amount. There are some other varieties of calcium carbonate. First, write down or just go through the various grades of whiting. See page number 4 near the bottom, specific gravity 2.5 to 2.8. Just read on your WhatsApp. Oil absorption is almost same for putty grade as well as this grade. Refractive index is also the same, but in putty grade the particle size is slightly higher. Even 10 micrometer particles may be rare in putty grade, while in paint grade only 2 to 5 particle size is useful. Normally, in good grade of paint, precipitated calcium carbonate is used, which is prepared in the laboratory. Starting with lime, react it with sodium carbonate. Whatever calcium carbonate is formed from limestone, it is precipitated. And this precipitated has got excellent properties, better than natural calcium carbonate. Then one more variety is there which is known as coated calcium carbonate. Please write down coated calcium carbonate. What is this coated calcium carbonate? We coat calcium carbonate particles by 3% stearic acid. Why 3% stearic acid? Because normally speaking, this calcium carbonate will not be very easy to disperse in oil media. It will have a tendency to repel the oil media because it is totally an inorganic material and you are trying to bring in contact or try to homogenize with an organic material. So calcium carbonate, if it is coated with stearic acid is an organic molecule, is it not? So if you coat it with stearic acid, it will be easy to disperse this coated calcium carbonate rather than natural calcium carbonate. Okay. So this finishes mostly our topic on white pigments. We can proceed now to our question and answer session.
So can you please restate the indirect process for manufacturing of zinc oxide?
Yes. Try to understand the difference between direct process and indirect. In direct process, the mineral, grinded mineral is directly used. Add some coke, heat it to a high temperature, say more than 500 degrees centigrade, zinc vapors will come out. And those zinc vapors are treated with a current of oxygen. That is how direct process is there. It was invented in America. The earlier process was a French process. In French process, you have to take directly the zinc sulfide. Here in direct process, we are blending with coal or coke so that it gets reduced to zinc. While here in indirect process, we are not doing that. We are using directly the zinc sulfide mineral and then it is heated directly without any additions. That is the main difference between the direct process but the quality of the indirect process is better. Try to understand this point, that quality of the indirect process is better because in direct process some lead sulfate is coming. About 5% lead sulfate is present as an impurity. Okay.
So what is the impurity percentage in indirect process?
Impurity percentage up to 5% lead sulfate.
Okay.
Sir, what is the seeding process in zinc oxide?
Yes, I will explain it. Zinc oxide is basic in nature. Try to understand. It is alkaline. Okay.
Yes, sir.
And all the binders which are used, whether it is alkyd resin, whether it is epoxy, whether it is polyurethane or whatever resins we are using, they are slightly acidic in nature. So titanium dioxide has no chemical reactivity. Okay. Zinc sulfide has not much chemical reactivity. But zinc oxide has a direct chemical reactivity with the binder. So what we are doing, if I use a smaller amount of zinc oxide, say 1 to 2% or 3%, that zinc oxide will react with that acid and form a soap, and this soap will disperse the whole mass very nicely. That is a positive use. But if I add 10% zinc oxide or 20% zinc oxide, then what will happen? It will go on reacting. Even in the container, if more zinc oxide is there, it will have a tendency to thicken up and convert it into a soapy mass which you cannot use as a paint. Means additional zinc oxide or excess zinc oxide will lead to spoiling of paint, while lower quantity of zinc oxide will be positive because it has anti-fouling property. It can fight with the algae. To some extent, it can cut the ultraviolet radiation. Then it will have gloss retention. Very small quantity. Some of the substances are there which are very useful in small quantity, but very useless in higher quantity. And that is known as seeding of zinc oxide.
Thank you, sir.
सर
Anybody else?
सर स्टेरिक एसिड क्यों यूज करते हैं सर कोटेड कार्बोनेट
Yes, yes.
कैल्शियम कार्बोनेट में
Calcium carbonate is an extender, is it not? Now, as such, it will have a very poor tendency to go into organic coatings. Organic binders कौन-कौन से हैं? Alkyd resin, epoxy resin, silicone resin. Most of the binders are polyester resin. All these resins are organic in nature, while our material is inorganic in nature. So when you try to make a paint, there is a fight. Calcium carbonate will have a tendency to come out. What we do for this reason, that we mix calcium carbonate with little stearic acid, around 3%. So on particle level, if a layer of stearic acid is deposited on calcium carbonate, then the whole material will be easier to disperse in the medium. Do you get it?
Yes, sir.
Coated calcium carbonate is little costlier, but it is more useful because it disperses very nicely and very quickly in the medium.
Okay, sir.
Anything else?
So are the extenders and filler materials one and the same?
Yes, they are the same, but I have already told you that extenders have a positive role also. They reduce the gloss, they homogenize the paint, they give a body to the paint. So there are positive aspects of extenders, and when used in smaller quantities, they have positive impact on the overall system. You have to judicially use extenders. Just as they are reducing the cost, if you try to use excess of extenders, that will spoil it. Fillers, although filler, extender, these names only indicate that the material is just used to reduce the cost. This is misnomer in fact. They are the auxiliary materials which in one way they reduce the hiding power, but in other way they reinforce the paint. That is the main reason. So I think we can close down. If you are comfortable and free, I think this is a good time. Friday, Saturday, Sunday.
Yes, sir.
Yes, sir.
Have you any examination on next Friday, Saturday? Yes.
No, sir.
No,
Any other engagement?
No, sir.
not yet.
Please check.
Sir, till now we don't know any engagement in the next week on Friday,
Okay,
Saturday, and
so
Sunday.
today we decide that we will meet on next Friday. Okay?
Yes, sir.
Okay, sir.
And be available, and whatever I will send WhatsApp message for type of notes I will circulate among you before starting the lecture. So that WhatsApp you can get a printout and you can use it for your study also. Okay? Thank you.
Thank you, sir.
Thank you, sir. Thank you so much.
Thank you, sir.
Okay. Okay.